Today on the Lab Report, we'll learn that a mineral is a natural solid with a characteristic crystal shape, that rocks are made of mineral pieces mixed together, and rocks form, break down, and move through the rock cycle. Hey, I'm Dr. Jeff, and today we're learning about rocks with some samples from my personal collection.
Rocks? You collect rocks? Why?
Yeah, rocks are everywhere.
Because rocks are awesome.
Oh, wow.
Those are pretty.
What's this one?
That is a mineral called amethyst. It forms large crystals, comes in many pretty colors. It's actually found all around the world.
And what about this one?
That is an arrowhead made from a rock called obsidian. It's made when lava cools down fast.
That's cool. How about this one?
That one is a mineral called pyrite, also known as fool's gold. It's shiny and yellow like gold, but it's not. Many people mistake it for gold.
What about this one?
Oh, yeah, or this one. How about this one, Dr. Jeff?
That one's purple. Oh, this one looks like a diamond.
Yeah, that's cool. How about this one? Looks like a shell.
That's nice.
Oh,
I
yeah.
forgot what this one was called.
I can't remember. Oh, what about this?
Doesn't that look like a booger?
Yeah, kind of.
This looks like hair.
Oh, it does. What about this one, though?
That's nice.
Oh, I've seen that before.
Okay, let's move on. Thanks. As you can see, rocks and minerals can be fun to look at, but they can also make our lives easier. For example, gabbro is a type of rock used to make roads. Granite is used in building material. Coal is used to make electricity, and shale is used to make bricks.
So what's the difference between rocks and minerals?
Good question, Caroline. Minerals, like this one, are natural solids that can be made of a single substance. They often have a crystal shape. Rocks, on the other hand, are made of mineral pieces mixed together.
Cool, but how do these pretty crystals form?
There are a few ways minerals can form. For example, hot water deep in the earth flows through cracks where it can dissolve different substances. Then, when it flows towards the surface, it cools, forms crystals.
Is that kind of like when sugar mixes with hot water and dissolves? Then once it cools, it forms sugar crystals again.
Yes, exactly. Let's demonstrate. First, we'll heat up some water.
Why does the water need to be hot?
Hot water can dissolve more minerals. When it cools, it can't hold on to all those dissolved minerals anymore, so they crystallize. Hot water can also evaporate, leaving crystals behind. Now, we just dissolve this blue powder into the hot water. Perfect. To form crystals, we simply turn off the heat and cool it down slowly. Here's one I cooled down earlier. See the crystals at the bottom?
Yeah.
Let's pour off the liquid and take a closer look. Check it out.
Wow, that's amazing. But how do you make bigger crystals?
You mean like this one?
Whoa, that is awesome.
This huge crystal is made of quartz. Small crystals form when liquid cools down fast. But in nature, it could take years for liquid to cool and form crystals. The slower the cooling, the bigger the crystals grow. This one formed over many years. It may look impressive, but it's actually not hard to find. In fact, most beach sand is made from quartz.
I know that glass bottles are made from beach sand, so that means they're also made from quartz.
Correct. Now let's learn about how rocks are formed. Rocks are made of mineral pieces mixed together. For example, this rock is called pegmatite.
It looks like a bunch of crystals mixed together.
Yes, each one of those pieces is a different mineral. This one is a mixture of the minerals garnet, quartz, feldspar, and mica. This other rock is granite.
Oh, I've seen this kind of rock before. It also seems to be a mixture of minerals, but these mineral pieces are much smaller.
Exactly. This piece of granite is a mixture of the minerals quartz and feldspar. Let's look at some more examples of rocks. One thing scientists do to better understand the world is categorize things, and that includes rocks. How would you put these rocks into 3 categories based on their appearance?
Well, these 3 have layers.
Great, let's put them together into a group.
Let's see. Well, these 3 look like a mixture of minerals pressed together.
Great, let's make them a group.
And that leaves these 3.
Sure. Great job. Scientists put rocks into 3 different categories based on how they form. These first rocks are called igneous rocks. The second group are examples of sedimentary rock. And the third group is metamorphic rock. Let's explore each one at a time. This first set of rocks are the igneous rocks. The word igneous is Latin for fire. When magma from inside the earth flows towards the surface and cools, it forms igneous rock.
Whoa, so those are fire rocks?
Exactly. This one is called obsidian. It forms when lava from a volcano cools too quickly to form crystals.
It's very shiny, almost like glass.
Yes, our Stone Age ancestors made arrows and axes from obsidian because when you break it, it can form a sharp edge.
Cool.
Amazing.
The next type of rock is called sedimentary rock, which is made of tiny pieces of other rock. You can see that it forms these straight layers.
Oh yeah, I remember this. The process of rocks breaking down is called weathering. Water, wind, ice, and even gravity can all break rocks into smaller pieces.
Then, those tiny pieces of rock, called sediment, are moved elsewhere. That process is called erosion, and it can be caused by wind, water, or even moving ice.
Then, the sediment is deposited somewhere else, where it can build up in layers.
And over thousands or millions of years, the sediment builds up and is compressed by the layers above. That makes it harden into sedimentary rock.
So, sedimentary rock is basically made from tiny pieces of other rocks.
Exactly. Now let's talk about the last type of rock, metamorphic rock. Sometimes rocks become buried deep in the earth where heat and pressure down there can change it. The rocks undergo metamorphism.
Did you mean metamorphosis, like when a caterpillar turns into a butterfly?
It's very similar. Metamorphism is when rocks transform into a new type of rock thanks to heat and pressure. The new type of rock is called metamorphic rock. For example, when granite is buried deep in the earth and subjected to heat and pressure, it is transformed into a metamorphic rock called gneiss.
Wow, the heat and pressure completely change its appearance.
Wait a second, how does a rock get buried deeper into the earth?
To understand that, let's review the layers of the earth.
The top layer of Earth is called the crust. That's what we stand on.
Under the crust is the mantle, which is about 100 times thicker than the crust. It's extremely hot, from 2,000 to 4,000 degrees Celsius, depending on the depth.
And the innermost layer is called the core of the Earth. It's even hotter, over 5,000 degrees Celsius.
Exactly. And Earth's crust is broken into large pieces called tectonic plates. Those plates slowly move over millions of years. Heat and pressure in areas where plates meet can form metamorphic rock. For example, when 2 plates meet, one of them can get pushed underneath the other, forming what's called a subduction zone.
The crust on one plate is slowly pushed down into the Earth. The rocks in that area get buried deeper and deeper.
That makes them heat up, and the added weight of all the rock above adds pressure.
Heat and pressure, that's what's needed to form metamorphic rock.
Yes, however, not all plate boundaries push rocks deeper. Sometimes rocks can be pushed up in what's called tectonic uplift, or slide past each other. These processes allow metamorphic rock to form, move, and eventually reach the surface. So we learned about the 3 main types of rock. Now let's learn how they're all related through something called the rock cycle. As we learned, when hot magma from deep inside the earth moves towards the surface, it cools to become
Igneous rock.
Then, over thousands of years, weathering breaks igneous rock down into,
Sediment, which is deposited in layers that harden into sedimentary rock.
yes, and if this sedimentary rock gets buried deep in the earth, heat and pressure will change it into,
Metamorphic rock.
excellent. That metamorphic rock could be pushed to the surface, or it could be pushed deeper into the earth where it melts to form magma.
And that forms a cycle.
The rock cycle.
Yes, those are the basics of the rock cycle, but it gets even more interesting and complex. Let's take it to the next level. Which of the 3 types of rocks could be broken down to form sediment?
Probably any kind of rock.
Right, so let's add arrows to show that any kind of rock can be broken down into sediment, which forms sedimentary rock.
That made the cycle more complicated.
Yes, but it is more correct, so let's keep going. Which type of rock can be buried and transformed with heat and pressure?
Well, again, probably all kinds.
Correct again. So let's add arrows to show that all kinds of rock can become metamorphic rock.
And any type of rock could be buried deep enough to form magma, so we should probably add arrows for that too.
Whoa, this diagram just got really complicated.
It did, but don't worry, you do not need to memorize it. Just remember the key concepts. Igneous rock forms from magma, sedimentary rock forms from sediment, and metamorphic rock forms from heat and pressure.
So with those simple concepts, we can understand any part of the rock cycle.
Now, let's explore the kinds of careers you can have studying rock.
Scientists called geologists study rocks. It's important to understand them because we get many everyday materials from rocks. For example, aluminum and copper metals are extracted from rocks that look like this. After extraction, those metals can be used to make everything from computers to cars. Rocks can also contain fossils, which are evidence of past life. Geologists study fossils and rock layers to learn about what life was like on Earth millions or even billions of years ago. Geologists can even study rocks on other planets. For example, we know that Mars appears red because rocks on its surface contain iron oxide, also known as rust. A mineralogist is a kind of scientist that studies minerals. In addition to being beautiful, minerals are useful. For example, the mineral quartz is used in our phones, watches, and other electronics. When you apply electricity to quartz crystal, it vibrates. That allows devices to keep track of time. Mineralogists help us understand useful properties of minerals and identify where on Earth they can be found. These are just 2 of the many careers that study rocks and minerals.
Today, I'll show you how to grow your own mineral crystals. To do this, you will need borax, a measuring cup, a glass container, food coloring, a pipe cleaner, a pencil, string, and hot water. First, have an adult help you heat 4 cups of water until it's almost boiling. Then, pour it into your glass container. Next, add 2 cups of borax and a few drops of food coloring. Now, mix it for 60 seconds. Finally, bend your pipe cleaner into an interesting shape and hang it from a pencil, like this. Now, place it in the solution and leave it overnight. Here's the batch I started cooling down yesterday. Nice. This is a mineral called sodium borate. It has the characteristic crystal shape. And here are some other examples I made earlier. Pretty cool, huh? In nature, one way mineral crystals form is when water is heated deep inside the earth, allowing a lot of minerals to dissolve in it. As the hot water approaches the surface, it cools slowly, leaving mineral deposits. Try it yourself.
Thanks, Adam. Now let's review.
Today, we learned that a mineral is a pure solid with a characteristic crystal shape.
Rocks are made of different kinds of minerals mixed together.
And rocks form, break down, and move through the rock cycle.
Join us next time on the Lab Report. I'm Dr. Jeff.
I'm Adam.
I'm Caroline.
And remember, always question, always wonder.